Good evening, everyone. I hope my slides are visible and I'm audible as well. So, today is an extra TA session, like a revision session. So, I have included like some around 2 to 3 slides from each week. The problems that we had discussed. I have also included some new questions for the week 3, 4, and 7. Uh, the other weeks, the questions are the same as the ones that we had discussed. So, we'll be discussing 2 to 3 questions from each of the previous problem solving sessions we had discussed so that it will be like a revision before your final exam. So this is separate from the weekly problem solving sessions. So this is just a revision session combining the syllabus of all the weeks. So let's start with the first week. So the format will be similar to the previous sessions where first I will display the question and then you can take 2 to 3 minutes to understand the question yourself and you can type the answer in the chat box. Then we can discuss the solution. So let's go to the first question. So in today's session, we'll be going a bit fast because there are many questions. So let the first question is, what is the importance of attitude and communication in the student advisor relationship? So during a PhD, it is the student advisor relationship is very important because the advisor will be guiding the PhD student, and so there has to be a good communication between the two, and there should be that willingness to learn. So the correct answer is option D. So if you have any questions, you can stop me anytime because I'll be going a bit fast today. Now let's go to the second question from week 1. So second question also most of you have got right. So to be a good researcher, it is not just advisable to only focus on your field. It is better to have an open mind and focus on the other fields as well because you may get motivation or inspiration from the other fields, and you may get new ideas for interdisciplinary research. So you have to be prepared and open mind, and option A, and there should be a receptivity to new ideas. So the correct answer are option A and option C. Okay, so let's go to the second week now. Yeah. So in this question, they have given a paragraph which has been given some citations, and they are asking what is the problem with the document. So the first option is citation should be always author year, but they are not. So citations, there are different formats for citation. So in some of the formats, you just put the author and year, and in some of the formats, there'll be a separate bibliography section with the name of the paper, name of the author's journal name, etc. So depending on the context, you can use any citation style, but whatever you should use just one citation style for one article. You should not mix different styles of citation. So citation can be author year, or it can be also in the format, this numbered format that they have given here. So option A is not correct. And option B, citation should be preferentially sequential, but they are not. So it is a recommended and good practice to keep the citations in the sequential order. Although it is not a compulsion, it is preferable. So option 2 is correct. And option 3, whenever there are multiple citations, usually the established practice is to write it as a range. So instead of writing 3, 4, 5, 6, you can just write 3-6. So option 3 is also correct. And citations cannot repeat, that is not a problem. It is okay if the citations are repetitive. So the correct answer is option 2 and option 3. Okay, if there are no doubts, we can go to the next question. This is from the week 3 syllabus. So this question is about deterministic versus stochastic processes. So in simple words, stochastic means more like random and unpredictable, but deterministic means predictable and it can be explained by equations, etc. So uh, the first option is deterministic means random, but it is actually opposite. Stochastic means random. So first one is false. Deterministic means non-random. And the second option, it is possible to have perfectly deterministic process if we are very careful about experiment. So in although like theoretically we can do say that, but practically it is very very difficult to achieve that, because in the real life there will always be some variable or the other that can't be exactly perfectly controlled. So C B is also correct. And C, amount of rainfall in India is stochastic. That is also correct, because right now it is not possible to predict the amount of uh, rainfall. And option 4, stochastic processes means predictability is 0. So this is not exactly correct. So we can't predict it with like a high confidence level, but at least a certain range we can predict. Like for example, taking the monsoon rainfall example, we can predict if it will be high or if it will be low, but we can't predict exactly how much millimeter of rainfall there will be, and not the prediction won't be always correct. So there it can be predicted to some extent, but not completely. So only the third option is true. Okay, I hope this is clear to all. We'll move on to the next question. So again, this is also a true or false question based on a little bit of statistics. So the first option is, suppose we are studying the trees of a forest, then what is the difference between the population and the sample? So population basically means everything, uh, all of the trees are the population. But suppose there are some 10,000 trees, it will not be possible to take all of them into the study. So we can select a small subset of trees from the forest, and this is called the sample. But in the option population and sample, the explanation have been reversed. So first is not correct. Option B, the mean of the height of all trees is the true mean height, and the mean of our observations is the sample mean. So, because we are not considering all the trees in the population for the study, there will be some differences in the observed statistics versus the actual statistics. So the true mean height means when we actually uh, the population mean, or considering all of the entire population, that would be the true mean height. But what we will actually do is it won't be possible to consider all the trees, so we will just get the sample mean by taking the mean of the just the trees in the sample set. And option C is, mean of a sample is both a statistic and an estimator. So this is also correct. So the definition of statistic is uh, any number that you get by performing mathematical operations from the observations of a sample set. So for example, in a mean, we are performing a mathematical operation that we are adding everything and then dividing by the total number of trees. And estimator means it gives, it something from the sample that we can uh, talk about the population. So from the mean we can talk, it is both a statistic and an estimator. Similarly, standard deviation, uh, they are saying that is both a statistic and an estimator. So standard deviation will just give the variability within our sample, but the mean can actually give an estimate about the trees of the forest. So standard deviation, it is a statistic but not an estimator. And the last option, estimator, is a kind of statistic. So it is true, because even for an estimator also we have to anyway perform some mathematical operation to get it. So 1 and 4 are false, 2, 3 and 5 are true. Okay, let's go to the next question. If you have any doubts, you can stop me. I'm just going a bit fast today because we are revising all the week's problems. Okay, let's go to the next question. So in this question, they are saying that the statistics are the same, like mean and standard deviation, those values are the same. But if you look at the data set itself, the individual XY values are different. So this kind of a um, set is called an Anscombe based data set. So they'll be having the same statistical measures, but the actual data will be different. But since the actual data points are different, when you plot it, obviously it will be different. So even if the statistical measures are the same, when you plot it, the uh, outcome will be different. So this is one thing to keep in mind, that although statistics are helpful in some sense, it cannot give everything about the data. So the answer to this is no, it won't be similar when we plot it. Okay, so let's go to the next question. So in this question, 1, 3, and 5 are the correct options. So we can go over all the options. Option 1, for estimates, confident regions, hypothesis testing, and errors should be reported. So similar to what I was saying, for example, when we are estimating the population mean by just measuring the sample mean, so it is not, we just, along with the estimator, we have to also say the confidence region, error bars, and which test we have, what hypothesis testing we have done. And option 2, confidence bounds are not needed for forecast. So forecasting again, that will also come under like estimating or estimator. So whenever we are estimating the population from the sample, we have to um, include the confidence bounds as well. And option C, use the Akaike information criterion and end use criterion if multiple models are identified. So these cri- sorry Akaike information criterion and end use criterion, they talk about the quality and the percentage of the errors. So especially if there are multiple models, then both of these have to be mentioned. So because these will give a measure of how well the our model is fitting to the data. So when there are multiple models, if we use these criteria, they will be helpful to identify which of the model suits the data better. And option 4, both underfitting and overfitting, both of them are a problem. So underfitting means the our model is not fitting the data so well, and overfitting means our model is only fitting the data that we have trained it, but when we it is not able to make any new predictions because it is so uh, it has overfit to our data. So option 4 is not true. And option 5, how to check if we have overfit the model. So if we to check that, we just have to give it some other new data and check if it is working with the old trained data as well as with the new data that the model has not seen before. So option 1, 3, and 5 are correct. Option 2 and 4 are not correct. Okay. Okay, let's go to the next question from week 3. Sorry, I think I was muted. So let's discuss the fifth question. So the first option is like a real life example where your friend is a little silent than usual. So here, like you notice that maybe something is wrong with your friend. So that is like a real life example of fault detection. And the second option is primary role of models used in simulations are for simulators are for prediction. So that is correct. So typically we build models to like predict what will happen to the system. So option 2 is correct. And option 3, models can be used for forecasting. Again, this is also correct, and this option is similar to the previous option. For example, even the weather forecast that we get, that is also built on a set of models about the weather. And option 4, models cannot be used for controlling a process to keep it close to a set point. So actually it models can be used for controlling uh, processes. So when we have already modeled something, then we can optimize which parameters to use, and we can keep the process under control. Like that is one of the reasons for modeling. So option 4 is correct. Sorry, option 4 is not correct. Option 1, 2, 3 are correct, and option 4 is not correct. I'll just update the slides and include the answer slide for this as well. Okay, let's go to the sixth question. So this question is about the difference between um, like a physical process and the model. So the physical process is the actual process that is happening. For example, it may be a production plant of a medicine where there are different steps in the reactor. So that is the actual process, and the model is that is what is modeling how the different variables like temperature and mixing rate will affect the yield of the medicine. So that is the main difference. Option 1 is correct because for a process it is like what is actually existing, so the input has to be like a physical input that we have to give. And option 2, the output of a model is the prediction of the model, so that is also correct. So in a model, we've like for example it can be a set of mathematical equations, and we will input the different variables, and the output will predict how much will be the yield of the medicine. And option C, there is no difference between model input and process input. This is not correct. Like it was covered in option 1 itself. Like for a process input, we have to actually give the input. For example, if the input is the concentration of the chemicals, then we have to physically add it in the process. But for a model input, we can just write the numbers in the equation. And option 4 is also not correct. Model and process have the same architecture. Again, it is the same difference that we were discussing, that the model is just there to predict it, so it does not exist in real life, like it's just a model. So option 1 and option 2 are true. Option 3 and option 4 are not true. Okay. Okay, let's go to the seventh question. So this is just a simple question, and today's session I'm going a bit fast because we are discussing a lot of weak syllabus. So just today's session will be a bit fast. We can discuss doubts at the end, or you can also just unmute and ask if it is a small doubt. Otherwise, we can discuss doubts at the end of the session. So the question 7 is, what are the two types of modeling? So the there are two main types. One is first principles modeling, and the second is data driven modeling. So first principles modeling means modeling based on the actual concept that is there. So that will need a physical understanding of the system. But data driven modeling means like we just have the inputs and the outputs, and we are just trying to write a mathematical equations to fit the data to the model. So here data driven, in the first principles modeling, the conceptual understanding will be more. So that is the main difference between first principles modeling and data driven modeling. Let's go to the eighth question. So here there are two examples given, and we have to find out whether it is a mechanistic or first principles modeling, or a example of data driven modeling. The first option is modeling an elastic element as a spring. So here we are actually using the conceptual understanding that springs are elastic in nature. So if there is any elastic component in the system, we model it as a spring. So that is an example of mechanistic or first principles modeling. And option 2 is we are measuring the temperature and precipitation in summers, and notice that it only rains on the days the temperature crosses a certain threshold. Here it is mainly data based, that based on the observations in the data, we are uh, forming a model that only if the temperature reaches a certain threshold, then it will rain. But there is no explanation as to why it is happening. It's just purely data based. So that is an example of data driven modeling. Okay, let's go to the next one. So the first option is, yeah, sorry, I was muted. The first option is true. The first option is success of empirical models depends on the quality of the data, because empirical model is we need the data to get the empirical model. And option 2, empirical models are good at extrapolation. So empirical models, once again, they are just trained, like it is similar to like overfitting with the data, because they just know the uh, data that we have used for the model, but it is not actually based on a concept. So for example, there may be a trend that for high values, the output, for high value of the input, the output follows a linear relation, but for the low values of the input, the output follows a quadratic relation. So in this example, if we are using an empirical model, and suppose the model has just the high value inputs, then if we extrapolate it to the low value inputs, the model won't be good at predicting it. So this is one of the issues with empirical models. So the data quality has to be good, and the range of the data also has to be good, and they are not so good at extrapolation, because it is just based on the data that we have used for the model, but in real world the data may be in different ranges. So the first option is true and the second option is false. Okay, so this we have just quickly covered week 3. If anybody has any questions in week 3, you can just unmute, because I'm not able to see the participants list because I'm presenting my screen. So I can just wait for 2 minutes, and if there are no doubts, we can go ahead with the week 4 syllabus. Okay, then I hope the week 3 questions were clear. Um, let's move on to the fourth week then. So, the fourth week syllabus is about technical presentation and technical writing. So this question is about making presentations and slides. The option A, animation should be limited to important information only. So this is correct, because if there are too many animations, then the uh, uh, participants may not, they will be distracted by the animations itself and they won't be able to get the point of the presentation. And option B, more and more the information in the slide the better. So this is also not advisable, because it is better to keep just the important information in the slide to grab the attention of the participants. And option C, it is enough to just read from the slide. So this is also not correct. I mean, some people do that, but it is not the best way to give a presentation. Then the audience will just be bored. So the point is that the slide will have just the important information and the explanation should be given by the speaker. And so if and it has to be done in a story, like in an interesting way. Option Last option, slide can be incomplete since presenter can fill in the missing information. So usually in slides it is better to put all the information, such that even if the speaker has not discussed about it, the slide should be standalone and the audience should be able to get the slide just by looking at it. So the slide should have the important message of the presentation, and it should also have uh, it should be standalone basically. Like, even if somebody is just looking at it without any explanation, people should be able to understand it. So only the first option is true here. Okay, let's go to the next question. If you have any doubts, you can just unmute and ask. Like I said, today we are covering all the week's problems, so I'm going a bit fast. So this is about writing a paper, specifically the abstract section and the conclusion section. So the abstract section is what will be present in the first starting of the paper itself. And the purpose of the abstract is so that even if someone is not able to read the whole paper, if they just read the abstract, they should be able to get an basic gist of the paper or the summary of the paper. So that is the main purpose of the abstract section. And so in the abstract, since that is the first thing that the reader will be reading, it is better to not use any uh, abbreviation or any jargon terms. So that is one thing. And the second thing is, uh, so in the abstract, typically what will be mentioned is the like one or two lines about what is the problem that has been addressed in the study, and the important results from the study. So just these will be discussed, and the future directions won't be discussed. So option A, more flexibility in conclusion section since the reader has read the rest of the paper. So this is true. Abstract, when reading the abstract, the reader won't be knowing anything else about the study, but when the conclusion section will be at the last of the paper, so they would have already known some jargon terms and some abbreviations. So here the writing can be a bit more flexible. And option B is not correct. We just discussed the important results in the abstract, not the future directions. And option C, important results are not mentioned again in conclusion since they are mentioned in the abstract. So this is also not correct. Again, the conclusion will be like a summarizing of the paper, and the important results will be emphasized again to bring out their significance. So even if it is mentioned in the abstract, it will be mentioned again in the conclusion section as well. And option 4, we already discussed that it is better to avoid jargon and abbreviation in the abstract. And conclusion can be a bit more flexible, and we can use it because the reader has read the rest of the paper. Any doubts? Okay, let's move on then. So the correct answer is only option 1. Okay, let's go to the fifth week. So the fifth week is creativity in research. So the first option, there is a small mistake. It is mentioned 1,000 hours, but it's actually 10,000 hours. So that's why the first option is not correct. And second option is about the second and third are about the intrinsic and extrinsic motivation. So intrinsic motivation means like the motivation that we get by ourselves, but extrinsic motivation means we are working because of an external factor. For example, the fourth one is the second. Here, the example they have given is of going to the lab. So, either we can go to the lab because we like the work and we are excited to see the result of the experiment. So, that is a more intrinsic motivation. But sometimes, even we may be forced to to the lab because there may be some abstract submission deadline or some report deadline, etc. So the option 2 is correct because when there is a manuscript submission deadline, that is an external factor which is making us to go to the lab. So it's an example of intrinsic motivation. But in the yeah, and third option is also correct. Going to the lab because you are excited about the result of your experiment is an example of intrinsic motivation. That is also correct. And option 4 is a little important to note, especially if you are in research. Only if you have tangible results, it means you have worked. So sometimes, especially, it's very common in research that we may be doing the work, but we may not always have a tangible output. And this is especially true in the initial stages of the research where we are still probably standardizing the experiments, etc. And this is also mentioned in the research output curve where initially the progress in research is slow, but uh, over time the progress becomes a bit faster. So the first one is not correct because it has to be 10,000, and second one, manuscript submission deadline, is an example of extrinsic motivation, not intrinsic. So there is a correction in the second one. Option 3 is correct because you are excited about the result, is an example of intrinsic motivation. And option 4, yeah, even if there are no tangible results, we have still worked, and definitely that work will somehow or the other contribute to the research. So these are the corrections that I have made in green. Any doubts, or we can go to the next question? Okay, I hope this question is clear to all. So this question is about the connection between stress and the level of performance. So the idea is that I there is a optimal level of stress that is good for productivity, and stress that is lower than that or higher than that both can actually decrease the productivity, because if the stress is too low, then the person may be very carefree and very careless. So that's why if the stress is too low, then the productivity will be low. On the other hand, if the stress is too high, the person will be too stressed out and anxious that they won't be able to think and they won't be able to work properly. So there is a middle zone where or an optimal stress level where the productivity will be optimal. So this is given by the Yerkes Dodson curve. So the correct answer is option 2. Stress in optimal levels is good. Is it clear to all? Any doubts? Okay, I think that is the end of week 5 then. Any doubts in the fifth week so far? If you have any doubts, we can discuss that. Otherwise, we can move to the sixth week. Okay, then I hope the fifth week is clear. So, the sixth week is about intellectual property rights mainly. So, this question is about what are the entitlements of somebody who has an IP right or an intellectual property right. So, intellectual property rights are used to protect the innovations and innovative ideas of inventors, and they do this by giving certain rights to the person who had first invented something or who has a novel idea. So the first option, right to file a suit in case of an infringement. So if somebody else has copied their idea, but they have already got the infringement, sorry, they have already got the IP right, then they can file a case in the court. So that is what option A is saying, and that is correct. And option B, right of excludability. Right of excludability means that only the uh, person with the IP right has exclusive rights to making their product or selling their product, etc. So this is the right of excludability, because the person with the IP right is given some exclusive rights. Option C, right of commercial exploitation. This is also correct, that if you have the IPR, then only you can exploit the product commercially. Like you can sell it commercially in the market, either you or anybody, like any licensed seller. So if somebody wants to sell your product, then they have to get a license from you. So option C is correct, and yeah, then all of the above. So if it is a multiple correct question, then you have to select all the options. Okay. Any doubts? You can just unmute and ask if you have any doubts. Okay, let's go to the next one. So when we look at IP rights, there are different kinds of IPR depending on the nature of the idea or the content. For example, uh, if because novelty can be in terms of a book or poetry or anything creative, so that would come under copyrights, and it can be a novel invention, so that will come under patents, etc. And in this question they have asked about the Reebok Delta symbol and Hyundai logo. So usually these logos and taglines, they will be covered under the trademarks IPR. So the correct answer is option 2. And I so this is just a summary slide of the different types of IP rights that are covered in the course. So each IP right will be covering different types of inventions, and each IP right will have different period of validity, etc. So, and there is a possibility of getting questions based on the validity and the definition of the IP right. So you can take a few minutes to go through it, and if you have any doubts, we can discuss that. I'll just wait 3-4 minutes so that you can go through the entire table. So this will more or less summarize the IP rights week. So I think all in this one, geographical indicator GI is missing, so that you can just refer from the textbook or the video. Okay, any questions or we can move ahead? Okay, I hope these intellectual property rights are clear. We'll also solve more problems based on IPR so that you get a better understanding. So this slide has about 7 questions, so you can take your time. Like I can give about 5 to 10 minutes, and you can type all the answers in the chat box. Then we can discuss them all together. Yeah, sorry, my laptop screen got stuck actually. That's why there was a delay. Uh, yeah, I hope everybody got the time to go through these questions. The first question is, which of the following is not a type of IP right? So, patents is a type of IP right to protect inventions, and trademarks is for brand logos and uh, etc. And geographical indication is for anything that is specific to a certain region. And human rights is not a type of IP right, so that is a completely different category. Option E, copyrights is for any creative work like book or songs or music. So the for the first one, the correct answer is option D. And option second question, what do patents protect? So patents is for invention. The other option, option A, is for literary and creative works that will come under copyright. And then yeah, so the third question is, what is the WIPO? So WIPO stands for World Intellectual Property Organization, and it is a organization that comes under the United Nations. So and this is important because IP rights are different in different countries. So another world organization that has some authority in international IP rights is the World Trade Organization, or WTO. And the fourth question is, what is the definition of IP right according to the WIPO? Option A is rights that protect products or creative labor, rights that protect geographical indication. So these are all like just a small part of the IP right and not the entire IP right definition itself. So there are a list of things that come under IP rights. So option D is the correct answer. Any doubts? Okay. If you have any doubts, you can just unmute and speak. So I am in the presentation mode, so I won't be able to see your if you have raised the hand or something. So you can just unmute and speak. Okay. Let's go to the next question. So this set of questions is about the different details of the patent. So when we are filing a patent, we have to do a patent specification in which the details about the patent and the methodology used has to be mentioned. And the second question is about the first examination report. So this will be the report that is given to the right holder or the person who has applied for the patent after their application has been verified by the IP right agency. And sometimes when a patent is filed and it is issued, then there may be problems. If somebody has a problem with that, then they can file that problem as well. So if there are any objections, then that will be taken up. For example, if somebody is filing a patent on something which is uh, already known, or if it is somebody feels that it is not novel, or somebody feels that they have copied a previous idea, then we can go for patent prosecution. So patent prosecution means raising objections over a patent application. And the fourth question is the different types of intellectual rights. And mm, copyrights and trade secrets. So B and C have trade secrets, and patents, trademarks, designs, and geographical indications. Okay. So option 4, I was just reading the options, and patent, trademark, copyright, trade secret, geographical indication, all of them are, they all come under IP right, and they have been discussed in the course as well. So the fourth one, all of the options are correct. And fifth one, what is the, so when I upload the slides, I'll just change this answer slide because geographical indications, that is also an IP right which has been covered in the course. So I'll just modify this slide to prevent confusion. Fifth one, what is the oral formula tradition? So oral formula tradition is just how knowledge was transmitted in the earlier days when there was no form of writing. So that is oral formula tradition. Any doubts? Okay, let's go ahead then. I have I have some more slides on IP rights, but for now I'm skipping because it's almost 7:40 now. So we can finish the week 7, and then if we have time, I'll just come back and discuss the other questions on the week 6. So for now I'm just skipping to the week 7. But these slides will be shared with you. So if you want to practice, you can practice all the questions. So the first question is, what is the importance of doing experiments? So these are more or less like basic questions. So to prove the theory, why is it important to quantify the scatter in experimental data? Because when, even though there is a linear relationship between the variables, when we actually do the experiment, we may find some variations within the experiment, and so rather than ignoring it or rather than trying to fix it, many of the times if we study it carefully, we can actually find out more things about the system and draw more meaningful conclusions. So option B is correct. And the next question, what should be done if a variable is not having a significant effect of the outcome of the process? So when we do an experiment, there are different variables that will affect the outcome of the experiment. So we will be trying to find out which variable is having which effect. And suppose we see that there is a variable, for example, let us take temperature. If the chemical, I'm just giving a rough example, that there is a chemical reaction and its rate is independent of the temperature, then we can keep that value fixed and we can just change the remaining variables which are changing the outcome. So the first one is option A. Any doubts? Okay, and these are just some standard basic questions about some little bit of statistics. So this question is about the normal distribution. So the normal distribution is a symmetric bell-shaped curved distribution where mostly the values in the middle will be high, and as we go to higher or lower values, then the probability of its occurrence will be decreasing. So that is the main thing about a normal distribution, that it is a bell shaped curve, and it is symmetric on both the sides. And to describe a normal distribution, we need the mean and the variance. So the mean will be the center point of the normal distribution, and the variance will be the how much the width of the normal distribution is. So if you have these two parameters, then you can describe the normal distribution. So the second answer, the question numbers are jumbled up, but yeah, the first question, the correct answer is option C. And the next question is, what is the notation for normal distribution? So we were just discussing that the normal distribution is described by the mean and the variance. So the mean is mentioned as mu, so that is the symbol of mean, and sigma is the standard deviation, and the variance is the square of the standard deviation, so sigma square. So it is described by the mean and the variance, so it can be given as mu and sigma square. So the correct answer to the second question is option C. And the next question is, what is the formula for standardizing a normal distribution? So usually from a normal distribution we can get the standard normal distribution. So to get the standard normal distribution, we have to use the formula x minus mu by sigma. So if there are some 10 observations, then all of the 10 observations we have to use the formula x minus mu by sigma. And if we do that, the mean of the new set of variables will be 0, and the variance will be 1. So the mean will be 0 because in the numerator we are subtracting it by the mean, so the new mean will become 0, and then we are also dividing it by sigma. So because of that division step, the new variance will become 1. So the formula for standardizing normal distribution is x minus mu by sigma. This one is option A. And the last question, what is the mean and variance? We just discussed that in the numerator we are subtracting the mean, so the final new mean will become 0. And since we are dividing it by the sigma, the variance will become 1. So the last question answer is option C, mean 0 and variance 1. Any doubts? Okay, so for week 7 as well, I have more questions. We can just discuss some like real life examples, so that will be easier. And then I think this will be the last slide that we can discuss. The other questions you can use as like practice problems before your exam. The other questions will be uploaded in the slides. So I can share the Google Drive folder where these will be uploaded, and it will be on the NPTEL portal as well. And today's class will also be recorded and uploaded. So the class recording is going on. Once the class is over, I'll upload today's class recording on YouTube, so you can refer to that as well. So we'll just solve this final slide and then we'll be done for today. Okay, let's discuss the solution to these questions. The first question is about the uh, so the fourth question is, in the fourth question they have given the 95 percentage confidence interval. So confidence interval means they will give a lower range and an upper range, like basically a range of values. And if it is a 95% confidence interval, then it means that 95% probability that the population mean weight will be lying within that value. So that is given by the confidence interval. So confidence interval is the range uh, within which the probability that the mean will be present. So fourth question, the correct answer is option A. There is a 95% chance that the population mean weight is between 250 and 350 grams. And the last question is, there is a company which is trying a new advertising campaign, and their belief is that it will increase the sales by 10%, and they are asking what is the null hypothesis. So the null hypothesis, it will usually be a statement that has no has no effect. So here the null hypothesis will be that if there is a advertisement campaign, then there will be no effect of the advertisement campaign. That is, the new advertising. So there are some more questions as well that we have not discussed today, but these are available in the slides on the Google Drive, and that will be shared on the NPTEL portal. So you can refer to that. So it's actually beyond time, it has crossed 8 o'clock. So that's it for today's session. All the best for your exams. If there are no doubts, we can finish the session for today. So we could not go through all the slides, but I just tried to cover all the week syllabus. There are some more slides as well that will be in the Google Drive folder shared on the NPTEL portal. So if you want some more problems to be solved for practice before the exam, you can refer to that. and the slides link as well as the recording link for today's session, both will be uploaded to the NPTEL portal. You can get it from there. Okay. And the Google Drive folder, if anybody wants, I can just put it on the chat box as well. So I have put the Google Drive link on the chat box. So this link will have all the week's problem solving session as well as today's problem solving session. And today's revision session will also be uploaded to YouTube. So I can give the playlist link where it will be uploaded. So this is the YouTube playlist link, and I'll be uploading it by tonight or by tomorrow. Okay, good luck for your exams.